A spot of mold is found on a basement wall. Its area is about 10 square centimeters. Here are the three representations of a function that models how the mold is growing. What do you notice and what do you wonder? Give me one thing that you see. Sekou, give me one thing that you see. The table and the graph. Yep. Yeah. Okay, in the graph, what's happening? Okay, cool, great. That's all I wanted. All right, so we're gonna revisit all of our key features, right? So domain and range in context. So remember, if it doesn't have context, that means like it doesn't have a word problem or a scenario, then you're just gonna treat it normal. But if it's in context, remember we can't have negative numbers. Okay. So in a biology lab, bacteria reproduce by splitting every hour. Each bacterium divides based on the pattern. A biologist is examining two different Petri dishes as shown in the graph and table below. Okay, so let's go ahead and find the domain and the range of this one. Different packets in the back. Oh, back card. Okay. All right, so domain. Let's look at this. Where do we start with our x values? Where do we start with our x values? How far to the left do we go? Zero. Okay, good. And then how far to the right do we go? Infinity, right? With our range, where do we start? 500. And where do we end? Infinity. Okay, normally they'll tell you like a cap of like 10 hours or something like that. But in this case, we're going to put infinity. We should be on page 2. Okay, for this domain, what's our first x value? 0. And how far do we go? Okay, so on here, this table only gives us a certain amount, right? So we can say from 0 to 3, that's fine, because it doesn't give us any more information, right? We could also kind of argue that on this graph, but since they have that arrow, it's going to be infinity. For range, where do we start with our lowest y value? And then what's our highest y value? Okay, now let me ask you this question. When bacteria grow, like, does it infinitely grow? Like, eventually it stops, right? Like, hopefully. Yeah, but like, all right, let's think about it. If I have like a Petri dish, that Petri dish can only fill up so much, right? Like, there gets to a point where there's too much bacteria in there and they can't grow no more, right? Because there's no more space. So really in this, we're not going to say infinity. We're going to say, well, since this graph only shows us up to hour 3, we're going to say 3 instead of infinity. Does that make sense? Because we're talking about in context. For this range, they show us that it starts from 500. And how far does it go? It goes to about, we're going to say like 5,000. So we're going to say roughly to 5,000. Graphs. Okay, so we're dealing with out of context. So we're just dealing with the function itself. Looking at this first one, what is our domain? How far to the left does this guy go? I don't know. It keeps going. It keeps going. So how far to the left does it go? Negative infinity. How far to the right does it go? Positive infinity, right? With range, how far down does it go? To 0. And then how far up does it go? Fantastic. Okay, so just to kind of remind you of something, this right here, what is this called? This line? The x-axis, but there's another name for this. See how this approaches but never touches? What is that called? Asymptote. Yeah. Okay. So this is your asymptote, this horizontal asymptote. Okay. So looking over here at this one, what number would be our horizontal asymptote over here? What's the number that would be the horizontal asymptote over here? -2, right? Okay, look at our equation. Where is that -2? It's this number that's out here. Remember over here, there's nothing written out here. That was 0. This one's -2. So whatever that number is at the end, that is your horizontal asymptote. Okay. Now, let's talk about the domain and range over here. Domain's going to be what? It's the same for all of them. So we'll be doing the last one. -infinity to positive infinity. And then range, we just talked about the lowest. What was our lowest? -2 to our highest, which is positive infinity. I need you to get comfortable with domain and range. Okay, one thing I do want you to notice, that out of context means that we can have negative numbers. We can also go to infinity. Okay, in context means we're not going to have negative numbers. Okay. In behavior. 3. Okay, so in behavior, remember, this is it when you're standing at 0, 0, and I say, hey, as you look to the right, what's happening? And as you look to the left, what's happening? Okay, so as we go to the right, what is this number, or what is this line getting closer and closer to? So as we move to the right, what is this number getting closer and closer to? You're all trying to say it, but you're not saying it because you don't believe you're confident in it. -6, right? Okay, as we move to the left, what's happening to our y values? Where are they going? Infinity, right? Okay, now in a table, it's a little wonky, okay? Because they don't give us the whole thing. They don't give us the equation. So we only see these 4 numbers, right? So as we move to 0, so as we're moving to the left, what number are we getting closer and closer to? So as we move to the left in our numbers, what number are we getting closer and closer to? 5. Okay. Notice how I put x approaches 0, not x approaches negative infinity, because I can't speak for negative infinity because I don't know where it goes. Okay. As x approaches 3, where does your y go?
Good morning, concept on interruption. Teachers at this time, please check your email.
Okay. So then we're going to say as x approaches 3, your y is approaching 625. Again, I can't speak for positive infinity because I don't know where this table would actually go. Okay, normally they use tables for in context problems. Okay. Another thing that you might see, and I just want to give this to you so you're not thrown off by it. If we're going to x approaches 0 from the right hand side, we're going to put a plus sign up here at the top because this means that I'm moving from the right hand side. As x approaches 3, we're coming in from the left hand side, so we're going to put a negative right here. That's just telling me the direction in which I'm moving. You normally won't see that often, but you could. Okay. So these questions, g of -2 and f of 2, you have to pay attention to which table or which graph is which. So when they say g of x, are they referring to the graph or are they referring to the table? They're referring to the graph, right? Okay, when they're saying f of x, are they referring to the table or are they referring to the graph? Okay, so that's the first thing that you want to know. So what are they asking me to do when they say g of -2? Well, that means that I'm going to take -2, look at the graph, and then tell me what the y value is. So what's the y value? -2, right? We're going to do the same thing over here, but they changed the number. They were trying to be sneaky. So when x is 2, what's my y value? When x is 2, what's my y value? 125. Okay. Those are the easy questions. Like, let those be the easy questions. There's questions like this on your SAT. Okay. I need you to make sure that you get these questions because there's always one on your final exam. Okay. Whatever the number is in the parentheses, that's your x value. Go find your y. What is the domain of this guy? It's the same for all of them. So what is it going to be? Somebody saying it. Negative infinity sub positive infinity, right? Okay. What is my asymptote? -3. The way we write this is as an equation. So we're going to say y equals -3. They like to trip you up because eventually we're going to talk about something called a vertical asymptote. Okay. So you have to make sure that you put y equals -3 to talk about the horizontal asymptote. Okay. Range. What's our lowest y value? It gets really, really, really close to -3, right? And then how far up does it go? Positive infinity. What's my x-intercept? Where does it cross the x-axis, roughly? 1.5. And you always want to put this as like a point, or you can put it as a list. That's fine too. What's my y-intercept? -2, right? Again, you can put this as a point, or you can put it as a list. Is this growing or is this decaying? So as you move from left and right, is it going up or is it going down? Up. So it's growing, right? Oh, what? Say again? Do you read right to left? No. So we keep it left to right. And that's normally how your eyes scan things. You go left to right in most cases. Yeah. Okay, so unless you're reading like manga books, then that's a little different. So, all right, so as x approaches positive infinity, so as we move to the right, what's happening to our y values? They're increasing, they're going to positive infinity. As we move to the left, what's happening to our y values? We're getting closer and closer to. Fantastic. Okay, is this increasing or is this decreasing? Okay, is increasing the entire time, right? So we're gonna say from negative infinity to positive infinity, it's increasing the entire time, and there's no decreasing. Look at this graph and table below. Which do you think matches each statement? Okay, I have a y-intercept of 100. Does the table, does the graph? Table or graph have a y-intercept of 100? Somebody said it. Table, okay? And how do we know that? Well, look at it. When x is 0, what's y? When x is 0, what's y? So this guy has 100. This guy has 200. Boom. Okay, on the next one, it says I have an asymptote at y equals 0. Okay, this is a little bit harder to see. Okay, so as we move closer and closer to, as we get farther and farther to the right, where is this guy approaching? 0, right? Okay, so this guy is going to have it. A horizontal asymptote at y equals 0. Also, let's make that make sense really quick. Caffeine milligrams. Caffeine milligrams. If you drink a cup of coffee, you're going to have all the caffeine. As the hours go on, it's going to go down to, you're not going to have any more caffeine in your system, right? We probably could say the same thing for this table as well. Okay, but they didn't give us enough information, so we're going to go with that graph. Okay, I have a domain of x is greater than 0. You have a domain of x is greater than 0. You don't have any negative hours, right? Same thing on this one. So you're going to say both on this last one.